Hello, I recently posted a short video about the stack data structure in which I demonstrated the simplest and easiest method to implement a stack data structure using the C language. In this video, I'll provide a detailed explanation of the implementation using the C language. Let's start. Firstly, include the necessary header file, which is stdio.h. It is used for printf and scanf statements. Next, we initialize top as an integer with a value of -1 and declare an array named stack with a size of 5. You can choose any size of the stack. Visualize it as boxes arranged on top of each other as shown. So we have 5 boxes in which we will put the values. Moving on to the next part, we have the two functions isEmpty and isFull. Both of these have a return type of integer. The first function isEmpty checks if the top value is -1, which means if the top is set to -1 or not. Visualize it like the bar hasn't touched the boxes yet. It is beneath the table. If that condition is true, it will return 1, indicating that the stack is empty. If the top value is equal to the size of array we created -1, which is in this case we have created an array of size 5. So I have written 5 minus 1, which is 4, to represent the last position. It means the stack is full. As we all know, array starts from 0 indexing and the top is at the last position, indicating that the stack is full. Next, we have three functions: push, pop, and display. The first one is the push function. It takes an input as an integer named value. In this push function, we have if statement where the condition is full. So when the user wants to perform the push function, the user will provide a value which will come into this function. It will check the if condition. If all the boxes are full, we can't insert the value into them, right? So if it is full, it will print stack is full, else it will go into the else block. Here we will increment the top value. That means if the top is at the first box, then it will move to the second box, which will be empty of course, and then put the value in it. Afterward, it will display that you have to put value into the stack. Next, we have the pop function. When we have to delete any value, we won't have to take an input for it. It will just keep on deleting the most recent values that you have added. If you go like 1, 2, 3 and start deleting, then it will delete the first number, that is 3, then 2, then 1, like in reverse order. That is why it does not take any value that has to be deleted. So the function does not have any input value, but it does have a return value, or we can say return type. Now in the pop function, we have an if statement with a condition same as the push function, but here we have the isEmpty function. If the stack is empty, then it will print that the stack is empty. You can see that I have written -1 in the if block, which is not mandatory to write, but it is a good practice. Written -1 indicates that the pop operation was attempted on the empty stack. Next, in the else part, it will decrement the top. Imagine you delete the value in the third box, then the top will move to the second box. Moving on to the next part, we have the display function, which obviously has the return value as void and does not take an input. Now consider that you have to open these boxes and see what's inside them. So you will start from -1, right, and move to the next by opening one after another box. So for that, if your boxes are empty, you won't have to check it, right? So in the display function, we have an if statement that checks if the boxes are empty, then print empty stack. Then we have the else block. First, it will print the stack elements, just to be clear when we run the program. Next, we have the for loop. We start from the 0 and move to the highest value of the top. If your top is at the 100th box, then it will go to the 100th box. But if your top has just 5 as I created, and you have put all the values in it, then it will just move to the highest value of the top, which will be 5. Then we increment it and print each value that has been stored in the boxes. So this was the implementation. Now we create the main function where we declare two variables, value and choice. We declare value because for the push function, that function takes the input as value. So we declare it here as well. Choice is used for the switch case that we are going to be using. We don't have any condition in the while loop. You can see that we have just written 1 in the while loop, which makes it always true, and block will always run. So in the while loop we can see we have a print statement that gives an idea to the user about which number is assigned to which operation and takes their choice in the choice variable. Then we will use the choice variable in the switch case. So it will check for the case number. If you select 1, perform the push function option, it will come to the case 1. In the case 1, as you can see, we have printf, which will ask the user to input the value that they want to insert into the stack. Then we will take their value, call the push function, and give that value to the push function. The push function will work, and then we will break from the case. Next, if asked for the second, the upper element which is recently added, and store that element in the value variable. We have used the value variable mostly to capture the result of the pop operation, just to display which element we have deleted. We have an if statement with a condition if the value was -1, like if the stack was empty, then it returns -1. In this case of an empty stack, it displays that we have attempted to pop an empty stack. Next, we have the third case where we just call the display function, it will do its job, then we'll break out of the case. Next, we have the case 4, which exits all the operation and the loop if the user does not select from 1 to 4 options and types another number, then it will print invalid choice.